Take a look at this problem. Suppose that an object is moving along the curve below. When it is at the point 1, 2, its x-coordinate is changing at 3.7 inches per second. How fast is the y-coordinate changing at that moment? And the curve is x squared minus 2xy plus 3y squared equals 9. Now, if we know the curve, that would be great. We know the point. We can see the point 1, 2 right over here. And there is an object moving along this curve. By the time it passing through this particular point, 1, 2, x coordinates is changing, y coordinates is also changing. And the question wants to know how fast is the y coordinate changing at that moment. Now, if you know the curve, that would be great. But if you don't know the curve, and if you don't have any graphing device to graph it out, that doesn't mean that we cannot engage this problem. Let's take a look at this problem one more time. Suppose an object is moving along the curve below. When it is at the point 1, 2, that means we know x is equals to 1 and y is equals to 2 at that moment. The x coordinates is changing. We are talking about the rate of change. Now, although you don't see the rate over there, it's hidden, it's a little bit tricky, but we got to understand that, hey, they are talking about the rate of change. And the rate of change of the x with respect to time, that would be equals to 3.7. Sometimes look at the unit, will give you a little bit hint. Inches per second. Second is the unit of time. So we are talking about the dx by dt. How fast is the y coordinates changing? Again, we are talking about the derivative. And the question is asking us to find the dy by dt. And that is the question. Let's see how we're going to engage that. We have the equation, we have the curve x squared minus 2xy plus 3y squared equals 9. So we are going to take the derivative of both sides with respect to t. The derivative of the left-hand side, we have 3 terms, so we are going to use the sum and the difference rule. Take the derivative term by term. The derivative of the x squared with respect to t, we use implicit derivative, 2x times dx by dt, minus the derivative of the second term. We're going to use the constant multiples rule, 2 times the derivative of x times y. So we have a product. It will be the derivative of the first times the second plus the first times the derivative of the second. Close the parenthesis, plus the derivative of 3y squared. We use implicit derivative again, 6y times dy by dt, which is equals to the derivative of 9 with respect to t, of course, will be 0. Now, every single terms here can be divisible by 2. So let's divide both sides by 2. That would give us x times the dx by dt minus y times the dx by dt minus x times the dy by dt plus 3y dy by dt equals 0. And now we are going to substitute x equals to 1, y equals to 2, dx by dt equals to 3.7 into the equation, giving 3.7 minus 2 times 3.7 minus dy by dt plus 6 dy by dt equals 0. And we are going to solve for the dy by dt. So we have 5 dy by dt minus 3.7 equals 0. That would give us dy by dt equals to 0.74. And don't forget to answer the question clearly. The velocity of the y coordinates changing at that moment is 0.74 inches per second.